Okay, I know it's not necessarily a good idea to show you mistakes, but here are some very, very popular mistakes for working with improper integrals. Big popular mistake for this is to not notice that 1 over x is undefined at 0 and that 0 is in the interval of integration, so this is an improper integral. A lot of people would just say, oh, this is the natural log absolute value of x evaluated from -2 to 2, which is what? The natural log of absolute value of 2 minus the natural log absolute value -2, which is natural log of 2 minus natural log of 2, which is 0. Wrong. That is the wrong answer. This is called not noticing that you have it's an improper integral, not noticing that 0 in the middle has a problem. So this is bad. Let's try again. Here's a slightly more subtle but also popular mistake. A lot of people say, okay, we split it up from -2 to 0 of 1 over x dx plus the integral from 0 to 2 of 1 over x dx. Being diligent, that 0 is where problems are happening. So what is this? The 0 is the problem. We say it's the limit as t goes to 0, integral from -2 to 0, 1 over x dx. Let's see, the 0 is the right-hand endpoint, so we approach it from the left using points, negative, somewhere between -2 and 0. And then we add to this the limit as t goes to 0. 0's on the left. So what is this? What is it? T to... Oh, wait. This is a t over here. You replace the t with 0, and that's going to 2. And t to 2, and t is going to 0. It's from the right now. 1 over x dx. So what do? We say the limit as t goes to infinity, goes to 0 from the left. What is it? Natural log absolute value of x from -2 to t plus limit as t goes to 0 from the right. Natural log of absolute value of x from t to 2. And so what have we got? We got the limit as t goes to 0 from the left, natural log of t minus natural log absolute value of -2 plus the limit as t goes to 0 from the right, natural log absolute value of +2 minus natural log absolute value of t. And then people say, oh, look, natural log of t minus natural log of t. Now I'm done with t's. And what do I have? I have negative natural log of 2 plus natural log of 2 equals 0, which we said before is in fact the wrong answer. What went wrong here? What went wrong here is you can't really cancel these things out. Sure, natural log of t, negative natural log of t, they're different. This t is going to 0 from the left, this t is going to 0 from the right. They're different things. Where did we go wrong? We went wrong when we used the variable t twice. If we say that in this particular integral, the 0 is bad, so you replace it with a t, and you have t approach 0 from the left, great. When you say that this integral is bad and this 0 is bad, so you replace it with a t is already used. You need to use a different variable. You need to call this s, as s goes to 0 from the right. Looks like pretty much the same thing. It is pretty much the same thing. However, when you get down to here, you will not be tempted to cancel these things out because they're different. They're different. And so what is happening? What is happening is, well, you look over here. T is going to 0 from the left. Well, thank goodness we're taking the absolute value because you can't plug in a negative number into the natural log. But is 0, as t approaches 0, from the left, whatever, the absolute value approaches 0 from positive numbers. As x goes to, as the value goes to 0, the natural log goes to -infinity. This thing right here is going to -infinity. That alone says, forget about this. Forget about this. The integral what we're doing. Negative 2 to 2, 1 over x dx diverges. If any one of your limits goes to infinity or is undefined, the whole thing fails. You can't have things cancel out, which is a little bit unfortunate in this case, because if you look at the graph, 1, 2, 1, 2, what are we going? 2, negative 2, what have we got? 1 over x, right? Y equals 1 over x. So 1 over 1, 1/2. So you've got this thing, and you've got the exact opposite over here. So a lot of people will argue, and it's the same sort of argument but a little bit more sophisticated, that this area, whatever it is the same as this area, except that this one is positive area, and this is a negative area. And a lot of people will argue, hey, if these areas are exactly the same, one of them is positive, one of them is negative, don't they cancel out to be 0? And the answer is, infinity minus infinity is not 0. Infinity minus infinity is not defined. It depends on how fast things are going to infinity. What we're really doing here, is we are integrating, from t to 2. And then we're having t approach 0 from the right. Did we do t for the one? No, that was s. We'll call this one. This one is s. And this one is t. I'll use red. What the heck? And then t is some value here. And we find the area from negative 2 to t as t approaches 0 from the left. And if you use the same variable, then they're both going to 0 at the same rate, but you're not guaranteed that. You don't know if it shouldn't depend on how fast the s is going to 0 relative to how t is going to 0. The fact that even one of these things is infinite means that the area makes no sense. The area makes no sense. It is not defined. If even one thing in your limit is going to an infinite thing, it diverges.